Hi, this is Shinchan. So, in the today's tutorial, we will be actually having a look at the decision tree classifier from Scalar. And we will be also trying it in WEKA without actually doing any coding with Python, right? So starting it with actually mounting our Google Drive, we will just use these two lines to actually mount our Google Drive here in Collab. Firstly, we have to actually import Drive from google.collab module, and then we have to mount our Google Drive in content/drive folder. So we will do it in a simple way by doing this. I have already done this, so I will not do it again. Then what we need to do is that we need to find a dataset. You can easily find any dataset from Kaggle, and for this particular case, we are actually considering a classification problem. A classification problem is a type of problem in which for the output label we have a predefined discrete set of classes and not a continuous ranged output. For example, this particular dataset, if you actually have a look, then we have particular set of categories or say discrete classes in which so that every of the record will actually lie in one of the classes. Here in this dataset, it is not actually a perfect dataset, and that's why I've actually taken it to actually show the situation that what you need to do in this kind of dataset. Okay, so in this dataset, what is the problem statement is that you are actually given the various categories of a pet, and then you have to actually guess the breed category of that particular pet. So what I have done is that firstly I've actually unzipped my that particular particular data set. I've got the dataset as an archive.zip, and I've actually saved it into my drive. What you can do is that you can go to Kaggle, like say Kaggle tabular classification dataset, shunt dataset, and it will show you a number of options to actually use for the decision tree classifier. You can just download that particular data from Kaggle and then come to Drive, then use this particular option to actually upload it here. And when you have actually uploaded, you just need to do in such a way that you will go to your particular location where you are actually able to see that particular dataset zip file. What I've done is that I've actually kept that particular file, I think, okay, not here, here. So I will just do what is that copy path, and then I will use the exclamation symbol and then followed by unzip command, and then I will just paste that particular path like this. And then what I will do is that I will unzip this particular folder. This will actually unzip this particular data into my drive here in this collab session. So what it is actually asking now is that whether it needs to replace the existing files with this newly unzipped files or not. So I'm actually supplying no because I've already unzipped it here. Now what I have done next is that I've just used this particular file and not the test one because there is a mismatch of columns and that might be an issue on that particular dataset side. So yeah, I'm actually using this particular file only for just example case. So yeah, how do we actually use to read a particular file as with pandas? We will firstly import the pandas as pd, means we are actually having a name alias of the pandas module with a shorter name so that we can use it frequently. So I've imported it with import pandas as pd, and then I've used the read csv function and supplied with the particular path of that csv file to actually read the database. What I will do is that I will just go ahead and into the file, and then I will right click and copy path, and then I will just paste it in, right? And then it will read that into a data frame by default. Now to actually have a look at the data frame, we can do what is that we can actually have a look at the first 5 records, right? And tail will actually give me the last 5 records. Here are all the records. Now we need to have a close look at the database, that what are the attributes we want to be in the x variable, that is as the x feature, and what are the attributes or say columns we want in the y variable. So as we are actually having a look, the pet ID is something which can be unique for each record, and that's why we will not include it into the X dataset, because what we want is that we want some other features which are actually deriving the output and not just the identifier or say primary class like columns. Now what we will do is that for that sake, we have our previous data frame into this pet data, and then what we will do is that to actually separate out only the x values, we will just use the drop command from that particular data frame to actually drop or say remove this breed category, that is actually our output, and this pet id also from this particular database. And as the second argument, one need to remember is that we need to actually supply these in these square brackets, and then as a list. And then for the second argument, I'm actually supplying x is equal to 1 to actually drop or say to actually remove from column wise. X is equal to 0 means row wise, so it will actually start looking from the horizontal axis and not vertically. Now I need to actually separate out my y variable also, means that is actually equal to the label. So what I will do is that I will actually get the breed category from my pet data using this. Then I will actually have a look at this particular dataset. It is not containing the pet ID and also not containing the breed category, because breed category is actually my y variable here. Now this portion is actually need to be skipped for now, right? Because I am actually using it for WEKA. So let's actually go ahead to the next portion. Now I'm actually having a look that how many counts does each value actually contain. So we have actually in this breed category, we have for the 0 class we have 9,000 records. For the 1 class we have 8,357 records, and for the 2 as the class, they have actually not provided any name for the class. They have just given 0, 1, 2, but yes, we can also use those. So for the 2 we have 1477. Now we will actually have a look that whether any value is null or not. So we will use is null function and then the sum along with it. Is null function will actually return all those records. That is, once you can actually visualize it in such a way that it will actually give us zeros for those which are actually not null, and the one where you have a null, and then summing all those ones will actually give us the count for those records which are actually having null, and it will actually show you column wise those values. That for the pet id, how many null values are there? There are no null values, and similarly 0 in each case because it is not actually having any null value. Now what we will do next is that we will just split our data into training and testing set. How we'll do it? We'll do it via the train test split function from the model selection of sklearn. So we will first import the train test split from sklearn.model selection, and then we will use a train test split with first argument being the x variable that we have actually separated just some time ago. And then we will also supply the y variable, and then we will actually supply the test size. The test size, as I have discussed also earlier, is actually the set size or say percentage which you want to keep for your test size. So we will actually supply 20%, that is 0.2 for now, and the random state being 0, so that it actually shuffles the data before splitting in the same manner every time I run on collab. And then it will actually return it into x train, x test, y train, y test variables respectively. Remember in such a way that it will first actually return all the x and then all the y, and firstly you need to do training, so x train and then x test, and similarly you will first do training and then testing, that's why y train and then y test. Now now what the problem is, we need to actually have a look at the problem soon. So you are actually able to see that here in this particular data set, where is it? In this particular data set we have this issue date also as being a string, and list okay, these are actually date types. Then we have other attributes like this one, which we can't actually use as a numerical value. Either we need to actually separate it out, or say you can actually also have a look at these categorical type values, that is color type. So you can't actually supply it directly to the classifier because it is actually having string values, and string, how will you do the calculation on string? And that's why you need to actually encode it. Now how do we use to actually encode these variables? They will actually be ordered in a say alphabetical sequence, like say they will be actually having an ascending order, and then we will just number every unique value with a numerical value, right? We will just sequence every of these values with every unique of these values with a number, and those number will be actually replaced there instead of these actual names. Like if I actually have a look, then the brown will be coming to first if I don't have any okay, so black will be actually coming at the top if I don't have any any word starting with A. So black will actually come to top, so it will be actually having a number of say 0, and then the next one in alphabetical order will be actually given the next number. Next, this how to do this. Okay, so we have another module that is category encoders in Python, which actually does this whole work for us. Otherwise we might have to do it ourselves. That's actually also not difficult, but yes, if we have module, then we must use modules. Okay, so we will install that particular module by using pip install category encoders, and from I will actually import that category encoders as CE. Then I will actually create an instance of ordinal encoder, and then I will supply all those columns which actually need to be converted to numbers from categorical values. That is, from nominal values I need to actually convert it into numbers. So I'm actually supplying the list of all those values which I will actually convert. Then I will use the fit transform function of this EC, that is ce.ordinal encoder, and then I will pass my whole dataset here, right? I have actually passed it here, and then I will actually save it, right? I am also saving this particular. Okay, so one thing you actually must note is that I can also save this particular data frame to a CSV file by using a function .to_CSV. And why I'm actually doing is that because I want to do something on this particular database in WEKA also, right? Whatever results I'm actually getting here, I want to compare those results from WEKA's decision tree classifier also, and that's why I am actually saving it into my collab session for now. So I will do what is that encoded pet data. I've actually just saved the transformed values of those particular data frame into this encoded pet data, and then I'm actually converting that encoded pet data frame to a CSV file by using to_CSV function. And here I actually need to supply the path in which my file will be saved and with which name. So what I'm actually doing is that /content/ and then pet data encoded.csv. This will be the name with which my file will be saved, and this is the content, because content actually belongs to your actually refers to your root directory of your collab session. Now after this particular step, I will be having this particular file here which I can actually use for my WEKA classifier. Now as this was the particular thing only done for WEKA, and for my this particular collab session, what I'm doing is that I'm also okay, let me actually have a look. Yes, after doing all this, what we are actually doing is that we are also encoding from xtrain also, right? That is, I must have did it earlier on the actual dataset, and that might have split it into test train. But yes, I can also do it later like this. I can again supply all those columns for which I have to do encoding into this columns is equal to and list variable, that is actually list type variable column, and then I will actually supply it into ordinal encoder, and then I will actually transform my xtrain and xtest by using ec.fit transform function, and then I will get my xtrain to be encoded version to be of encoded version, and xtest also to be an encoded version. Now what I'm doing next is that I'm actually importing the decision tree classifier. So till now, let me summarize that what I have done is that firstly, we have actually loaded the dataset. Then we have actually checked for the null values, and also actually got those sum of those values which are actually null, and we have found that nothing was null. Next, what we have seen is that we have actually just splitted our dataset into train and test size by using the train test plate from model selection. Next, what we are actually doing is that we are importing the decision tree classifier for actually classification purposes, and we need to fit that training data into this classifier. So from sklearn.tree, we can actually import decision tree classifier, and in that decision tree classifier, I need to supply some values on the parameters on which the decision tree classifier will actually work. The first parameter is actually criterion, that actually gives it the parameter on which it will be actually supplying or splitting the values. Well, you have actually two options, that is that first one is actually Guinea index, and then the second one is entropy. The Guinea index is actually something measure to actually calculate the impurity, and entropy is same, and they actually follow different approaches, two different approaches to actually calculate the impurity and to actually give the model insight that how it needs to split the data to actually get to the end to actually classify the particular records into labels. And then as the second argument, you actually need to supply the max depth, and the max depth is actually set to 3 for now, right? What this argument does is that it actually limits the height to which the decision tree will actually grow. Otherwise, there might be a situation that decision tree might grow to a very long level and might not also stop because you might have not those attributes. So yeah, you actually supply the max depth to be 3. That is, you exactly want the height of the decision tree to be maximum 3. And then here also you actually supply the random state to actually always classify in the same way or always split in the same way as you have did earlier. And then what you will actually do is that with the fit function, you will supply X train and Y train as the argument, and then you will fit your model. Now, after you have fitted your model, the training is complete, as decision tree actually trains very fast. So we have our model already trained, and then what we will actually do is that we will actually import the metrics from the sklearn.metrics module, and then we will actually try to have a look at the various metrics, or say evaluation measures, or say the values which will actually judge that how much good your model has trained. So we have actually imported the accuracy score, precision score, recall score, and confusion matrix. Confusion matrix is actually a matrix like this, where you are actually, which actually tells you the insight about how much values are actually predicted, right? Which you are actually of the same class, right? And they are also predicted to be of the same class, and how many values are actually predicted of a different class. So according to the number of classes, this matrix is actually constructed. If we have 3 classes, as we have seen, we have only 3 classes, 0, 1 and 2. So we have a 3 cross 3 matrix here. And then if we have 4 classes, 4 class variables, it means 4 output variables, or say 4 categorical values in the output, then we might have 4 cross 4 matrix. So for actually calculating the accuracy, you just need to pass the X test, Y test, and Y pred in this particular. Now what are actually a Y test and Y pred variable? Y test is actually a variable which contains the real Y labels according to your training examples, and Y pred is actually the variable which actually contains the prediction of those particular records that is actually made by model. Now how to get the Y pred? So we will get the Y pred through DT. DT is actually the classifier which I have actually constructed, that is decision tree classifier. D, T and C are actually capital A. So we will actually use its predict function on the X test value. Remember, X test were the actual records, or say X values of those records which are in the test set, and we need to actually find the Y values of them. And when the model has actually found the Y values of them, it actually stores them into Y pred. Then what we will do next is that it will actually calculate the accuracy score of those, like Y test and Y pred will be actually passed in, and then it will actually calculate the accuracy score. What actually accuracy score is that it actually sums up the diagonal elements, because the diagonal elements are the ones which actually tells you that these are the right predictions, right? It was this class and it has predicted the same class, something like that. So, and it actually divides it by the total number of values, so say total number of records. Now precision recall are those metrics which are calculated in case of imbalanced class, means highly valuable in case of an imbalanced class. But yes, we can also have a look at these here also. Now what is this average argument, or say average parameter here being passed, is that by default you have average is equal to binary in the precision score and recall score. And now because you usually used to do calculations on a 2-class problem, but here you can see that we have a 3-class problem, that is 3 output variables, so say 3 values for your classes are there. So you need to actually supply some other argument of average. So we are actually supplying none here. That actually means that it will actually calculate the precision score for according to each class and will output them here. Now what we need to do next is that we are actually trying to visualize, or say plot our decision tree which actually has been classified yet, or say which actually has been trained yet. So what we are doing is that firstly we are actually importing the matplot.pyplot as plt, and then we are actually constructing a figure with the figure size of say 12,8, that is 12 will be its width and 8 will be its height. And then we are actually importing the tree from sklearn. From sklearn we have imported tree, and then I will use the plot tree function of the tree to actually plot this particular tree, right? Tree.plot tree, and then you will supply your classifier in the braces for that plot tree function. Now classifier was actually stored in dt, that is actually decision tree classifier, and then you will supply it here and it will automatically just plot it here. Now you might there might be a case when you might want the text version of your decision tree classifier. So what you will do is that from the same module, from the sklearn which you have imported tree, from the same module you will use the export text function, and then you will supply the dt as the argument. And then when you will actually print that text decision tree, then you will actually have a look at something like this, which is the text version of that decision tree. And then we also have another option of graph that actually gives you a beautiful look of the same decision tree. So how to actually use this graph function? So firstly you need to do is that you need to actually install the graph by using the pip install graph, and then you will import the graph, and then it actually was creating an error that my y values were actually of the type integer, and it was actually expecting the y values of type string. So what I've done is that I've created a list, and then for each y value in my y train I'm actually just casting that particular y value into the string, and then appending it into a list. Then in the tree.export graph method, what I'm doing is that you have actually two steps to use this graph to actually plot your decision tree like this. Firstly you actually need to create a dot data, and then you need to supply that dot data into the graph.source function. So dot data will actually have the value of tree.export graph, and first argument will be your decision tree classifier. Then you are actually saying that you don't want to actually save this particular file, that our file is actually equal to null. And then you have the feature names, that is what are the feature name of your x variable. So you are actually having those values into the x train.columns, and then it will actually want your class names. So you have those class names in the say stry train, and then you are actually supplying some other arguments like filled is equal to true and rounded is equal to true. That means you want to actually fill those boxes, and then you want them to be rounded or not, and then special character is equal to true. And then in this way we will be actually saving this information to dot data. There's actually another format of storing your decision tree classifier, and then you will actually supply that argument into your graph.source function, and then printing that graph will actually give you something like this. Then there is another library that is actually dtreeviz that actually helps you visualize your decision tree. So what we will do is actually firstly we will actually install that dtreeviz by using pip install dtreeviz, and then we will do what is that we need to also import another some other modules for the trace, because sometimes there are actually two ways to actually print this the tree by using ipython the display function, or maybe okay, so let me actually talk about it later. So firstly how you will actually use the tree firstly you will actually supply the argument of classifier, and then you will supply your x train variable that is actually containing all the x train elements, and then y train variable which is actually containing the labels of those x values. And then we have the target name is equal to breed category, that is actually my target means say output, and then output, or maybe say output class. And then we have the feature name into x train.columns, that is actually referring to all those names belonging to features. And then his type is another argument that is all on the bar stack. For now we can actually change it to actually give another different type of plot. Then printing on this will actually get us something like this, which is actually a better visualization in compared to previous one, and it actually gives us better insights of that decision tree. Next this is actually just a WEKA work. And now what we have done so far is that we have actually just visualized our decision tree classifier, and we have also just trained it into Python. Now how to do it in WEKA, and what is WEKA? WEKA is actually a particular Java program, say particular Java software, which actually helps you to actually do all the machine learning without coding in Python. Right, you actually just need to choose your data set and you can just train your model, which are actually available there with a lots of customization in the parameters. And then you will do is that you just need to actually find a good data set, and then you can actually do all the training, pre-processing, and all the work in this WEKA. So how to get started? So remember, if you remember, I have actually saved the data set into my collab. So what I will do is that firstly I will actually download this particular data set. I can do by right clicking that particular data set and then downloading the data set, and I will show you the errors also which actually happens if you actually follow this approach. If you remember, what I've done is that I've actually just saved my data frame to CSV by using to_CSV function, and then I've actually saved it, and then what I've done is that it has actually been converted into a CSV file, and it is actually available here. And then with the right click, I've actually saved it into my local system. Now, if I actually directly try to import this particular data set into WEKA, it will actually give an error. Now, what's the first option for that? You will first go to Explore, and then it will actually take you to this particular window. Then you will go here on the open file function. That's actually lets you select your database. So as far as I remember, it will be actually saved in the downloads here, and then it will actually not show any file because it is by default finding ARFF type file. So you need to actually change it to CSV type file. And then which file was it? It must be this particular file. Let me actually have a look at again. Okay, 14. So this is this particular file, and if I actually want to import it, I will click it. Now it will actually give an error. Now what's the actual reason for that particular error? Let's actually have a look at that. So if I actually see that particular file, I will open this particular file. Now when data frame is actually saved to a CSV file, by default what it does is that it will actually give a serial order of those records also. So we need to actually remove this. So how we will actually remove this? We will just click on A, that is a column here, and then we will press delete. And then similarly we will select all the columns by using shift, and then we will just cut and paste and shift those columns towards left. In this way we will be actually just removing that particular column, and now the error must not come. Now if you try actually to import that particular data set again, then it must now get us that particular data set. So as we have seen, it has already given that particular data set to us, and it is trying to visualize that data set, right? Now, another problem that actually has happened is that actually happens in WEKA is that it actually looks at the output variables. If we now try to actually do all the classification in that WEKA, then what it will do is that it will actually treat it as a regression problem, because I might give this particular column that is actually breed category to WEKA to actually classify by keeping this as in mind, and it will actually see these values, and these are actually numerical values, and so it will actually try to think that it is a regression problem, not a classification one, and that's why some issues might occur. While actually I was actually wanting to get the confusion matrix or maybe something else, so there will be issues. So what I will do is that I will find 0 values there, and then I will replace it with a class, right? Replace all, and then I will find 1 as the class, and then I will replace it with B, and then I will find 2 as the class, and then replace it with C. So in this way I will be actually having I will be actually left with only these as my values. So this will be actually serving as classification model to WEKA, and instead of a regression model. And so I will just replace all the values from this particular column only. So if I go ahead and save this particular file, and then again try to import this file into WEKA, now I've actually imported this particular file. Now let me actually go to this classify tab from the top, and then I will choose a classifier. So in this tree section, we have different trees actually available here. We will be actually using REP tree. And then here you have actually a lot of options that you actually might want to use. There is a cross validation, that is actually k4 cross validation, and k value is actually being supplied here. I will use a percentage split because I've done the similar thing into Python module, or say Python collab also. So I'm actually setting the split to be 80-20, and then I need to actually supply the y value, that is your label here. So I will actually find the breed category here, that is actually a nominal now. Otherwise it might have shown the NUM for the numerical attribute. Now what I will do next is that I will go here and I will just apply the max depth to be 3, and I will also supply the, say, debug is equal to true to actually print the information when it's actually classifying. Now there is another argument, that is actually no pruning, to which we can actually set to true. That actually means that you don't want the pruning effect of this by default WEKA. That is actually what it does, is that it actually prunes the unnecessary branches from the decision tree classifier. So it is actually by default pruning, and that's why it's actually set to false. And if we actually set the no pruning to true, then it will actually just remove it will actually stop pruning those excess branches, and then you need to actually click on OK, and then you will click on start. So yeah, your classifier is actually trained, and you are actually able to look at those confusion metrics, yeah, right? And then what next? Okay, so this is actually a confusion matrix, and these are all the evaluation measures or say score which you might need to compare with what you actually got into Python. And then to actually see what tree has been actually made, you just need go here on the latest run, and then you will just visualize tree. So okay, so there is some issue. Let me actually have a look at it. Okay, so the issue is actually that there is another attribute here, that is actually pet ID, which we have actually removed when we were actually working with the collab, but we have not removed it here. So while actually you are actually looking at the pre-process tab, then you can actually remove that particular attribute. So you will click on that particular selection option there, and then you can just click on remove, and it will remove that particular attribute from your options. And then go on the classify, and then with the same options you can just press start, and it will actually get you. After actually you need to again select the breed category because it has refreshed its database, and then you will actually press start, and then you will get the confusion matrix. And on right clicking that particular latest one, you can just visualize tree, and yeah, it has actually not pruned. So what I can do is that I can go upwards, and then I will just supply 3 as the max argument, and then click OK, and then I will again run, and then have a look at the tree by going to the right and these options. And this is my tree which actually has been made, and you can actually count that these are the maximum 3 as your depth, 1, 2 and 3. And then you can actually fit to center by right clicking and fit to center, and then you can take the screenshot of it, and take you might also take the screenshots or say text of these confusion matrix or say evaluation visa, and then might compare with the results which you might have got from Python. So yeah, thank you for watching, and have a nice day.